Linear Regression and Linear Correlation and Regression Analysis, Chapter 4. This lecture will cover the second half of Chapter 4. We're going to continue our discussion on linear correlation, and we're going to get to a second part of the lecture called regression analysis. Okay, linear regression analysis. In the real-world application, which is what we put into our calculators at the end of the last lecture, that was the number of years of schooling and the life expectancy for a set of about 12 sample countries. We saw that a positive linear correlation exists between a country's average length of schooling and life expectancy. What if we wanted to estimate a country's life expectancy simply by knowing the average length of schooling? So, in other words, what if we wanted to estimate for a country not in the sample what the life expectancy would be given a known average length of schooling? So, knowing that there is a significant linear correlation from the sample data, we can create a line that best fits the sample data. Then we can use the line to estimate other values for countries not part of the sample. So in the past, you may have done algebra using linear equations, which are lines, and you may have been able to use the line to find a y for an associated value of x. Basically, that's what we're going to be doing in this section. We're going to be finding the equation of a line, and then we're going to be using that equation as a predictor for a value of y given a value of x. Okay, so a linear model, which is basically an equation of a line, can be developed to predict a value for the dependent variable y given a value for the independent variable x. So our x is always the independent variable on the horizontal axis, and our y is always the dependent variable on the vertical axis. So what we can do in this particular problem, we can be given an independent variable x, a value. So say, for example, average length of schooling is 13 years. Based on that value for x, we can use the line to come up with a value for y, which is the average life expectancy. Okay, so for example, a strong positive correlation has been shown to exist between high school students' standardized test results and the success the first year of college as measured by the students' GPAs. By creating a linear model, an equation of a line, we can predict the first year college success of a student with a particular standardized test score. Okay, so in this example, there's a positive correlation between standardized test results and student GPA in their first year of college. Which of those two variables should go on the horizontal axis for x, that's the independent variable, and which one goes on the vertical, which is the dependent variable for y? Well, the independent variable, basically you can think of that as the value that comes first among the two variables. So in this case, the value that comes first is the standardized test results. That's going to be the value for x. That's going to be what x represents. And the student's GPA, their first year of college, will be the value for y, the dependent variable. Okay, so what we're going to do is create, if we had raw data for this particular example, we can create a linear model, which is an equation of a line, that basically fits among the points of the scatter diagram. And with that line, we can make a prediction on first year college success if we were provided with a particular standardized test score. So we could be given x, and then we use that x to predict y. Okay, linear regression analysis provides us with a linear model and equation that can be used to predict the variable of the y variable, college GPA, given the value of the x variable, the standardized test scores. The predicted value for y may not be exactly correct because it's used as a predictor, so it's not necessarily exactly correct, can't predict the future, but it's going to be a close estimate. The line that is created by linear regression analysis is called the best fit line between the points that is positioned closely among all the sample points, and this is called the regression line. So here's an example of a scatter diagram, blue dots, and a regression line is positioned among the points so that the line falls in between the points. You'll have some points above the line and some points below the line, and the line is positioned so it's perfectly positioned between the average of points. Now, you can't just randomly put the line wherever you think it belongs. The equation is actually derived at using a mathematical formula and incorporating all the x and y values for all of the points. So using all those x and y values for all the points, we come up with the equation of a line, which, if you're familiar with the equation of the line, is of the form y equals mx plus b. The slope is going to be found by using the x and y coordinates of the points as well as the y-intercept using the x and y coordinates of the points, and then we could come up with the equation of a line. Here's the formula. Y equals ax plus b. That's what we're going to be using in this class, where we know that the coefficient of x, if you've seen this before, mx or ax, the coefficient of x is the slope and b is the y-intercept. Y, with this apostrophe next to it, we're going to say y prime. Y prime is the predicted value of y, the dependent variable, given the value of x, the independent variable. So perhaps you were given the student's test score, then you can simply plug into the equation for x, plug in x, and get out a value for y, which will be your predicted GPA success in your first year of college. Okay, a and b are regression coefficients. You know, they're the slope and the y-intercept. They're obtained by the following formulas. The a part, the slope, looks like this. Okay, we've got n summation xy minus summation x summation y. Okay, it's kind of complicated. So similar to what we did when we found the correlation coefficient, we're not going to find a and b by hand, although the textbook does go through it. So if you want to go through this manually and step by step work it out by hand, you are welcome to look at the examples in the textbook that show you exactly how to do that. But the calculator is going to be the way we're going to do it in this class, the same way that we found the correlation coefficient. Okay, so the textbook, just beware that we're not using the formula as shown in the textbook, which is y prime equals a plus bx. Okay, what's the difference? Well, if you take a look at our equation, y prime equals ax plus b, a is the slope, b is the y-intercept. In the textbook, they use y prime equals a plus bx, where b is the slope and a is the y-intercept. So if you use the textbook for reinforcement, just beware that we're not using the same formula. Okay, going